Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on January 5th, 2026, just yesterday. It introduces a unified autoregressive model trained on 6 trillion tokens that achieve state-of-the-art performance while generating 1024 by 1024 images in just 5 seconds. The paper is titled NextFlow, Unified Sequential Modeling Activates Multimodal Understanding and Generation. And as we'll see later, the implications for efficient, high-fidelity multimodal generation are quite significant. And for those interested in the implementation, the authors have shared their code on GitHub. Alright, let's look at the system design. Figure 1 shows the NextFlow architecture, which processes interleaved sequences of text and image tokens as a single input stream. The core component here is a unified decoder-only transformer, which handles both modalities together. However, the output generation splits strategies. While text is predicted token by token, images are generated using next-scale prediction. This means the model builds images hierarchically, starting from core structures and refining them into details. So what does this unified architecture actually produce? Figure 2 displays a gallery of samples generated by NextFlow. You can see a remarkable range of aesthetic styles here, from traditional inkwash paintings and sketches to highly realistic portraits. It handles surreal concepts like doors opening into clouds. It also renders legible text, as seen in the central graffiti. Finally, the strip along the bottom demonstrates its ability to generate consistent, wide-format cinematic scenes. Moving to the training recipe, Figure 7 outlines the multi-stage pipeline and its impact on the GenEval score. The top diagram breaks the process into distinct phases, starting with alignment and moving through 3 phases of pre-training that scale resolution from 256 up to 1024 pixels. Below that, the chart tracks performance over nearly 6 trillion tokens. We see a steep rise during the initial pre-training, followed by steady gains as the resolution increases. Finally, the green section on the right shows how post-training techniques, like supervised fine-tuning and reinforcement learning, provide that last boost in quality. While the previous figure covered the overall pipeline, Table 1 addresses a key concern about data mixing. It lists GenEval scores to check if adding text back into the training loop hurts image generation. The first row shows a pure text-to-image baseline, while the second row includes 25% text data. As training progresses from left to right, the scores remain practically identical. By the final column, the mixed model hits 0.499 compared to the baseline 0.505, proving that maintaining text capabilities doesn't degrade visual quality. Alright, Table 2 details the exact training recipe corresponding to the pipeline we just discussed. It breaks down the stages from initial alignment through 3 phases of pre-training and finally to fine-tuning. Notice the heavy lifting in the second row. The 256-level pre-training consumes 3.4 trillion tokens, representing the bulk of the learning process. As the resolution scales up to 512 and 1024 pixels, the data volume naturally tapers off. Then, the bottom rows show the CT and SFT stages, which use much smaller, high-quality datasets at full resolution to refine the model's output. So, having detailed the training recipe, Table 11 presents results on the author's proposed Edit Canvas benchmark. This table divides evaluation into 2 primary categories: standard edit tasks on the left, covering global and local modifications, and subject-driven generation on the right. The bottom rows highlight the performance of NextFlow and its reinforcement learning variant. Notably, NextFlow RL achieves a comprehensive overall score of 8.04. Its strength is most visible in the subject-driven section, where it scores 8.78, demonstrating it can edit scenes while robustly preserving the subject's identity. Wrapping up, NextFlow demonstrates that a unified autoregressive architecture can effectively bridge the gap between multimodal understanding and high-fidelity generation. By switching to next-scale prediction, it offers a scalable alternative to diffusion models that is both fast and semantically powerful. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.